Here is the ratio test. We're going to use it to determine the convergence of this series, whose terms are n to the n divided by n factorial. We know from the ratio test we must assess the limit of the absolute value of the ratio of consecutive terms of the series. So in the numerator, we put a n plus 1. That's found by just plugging in n plus 1 in place of n. Thus, we have n plus 1 to the n plus 1 divided by n plus 1 factorial. That's an plus 1. Then we divide by an, the nth term of the series, which is just n to the n divided by n factorial. Now, dividing by a fraction is the same as multiplying its reciprocal, so let's rewrite. Rewriting the fraction gets us here. We have n plus 1 to the n plus 1 multiplied by n factorial divided by n plus 1 factorial times n to the n. Now, n factorial and n plus 1 factorial will almost completely cancel out. It's just going to leave behind a factor of n plus 1 in the denominator. Since we'll have an n plus 1 in the denominator, we might as well take one of these n plus 1s out so that they can cancel. Because we have n plus 1 factors of n plus 1 here, so let's just take one of them out. That gets us here. Since we took one factor of n plus 1 away from the n plus 1 factors, there are now just n factors of n plus 1. The n plus 1 that we took out, we can cancel with the n plus 1, which would remain in the denominator. We also, of course, have n to the n in the denominator. We also drop the absolute value because all we have here are positive integers. So doing that cancellation, we have n plus 1 to the n divided by n to the n. We can take the exponent out and just write that as n plus 1 over n, all to the power of n. But then if we split this fraction across the addition, we would have n divided by n, which is 1, plus 1 over n. Thus, we would get here, n divided by n is 1, and then we would have the 1 over n. So we have the limit, as n goes to infinity, of 1 plus 1 over n to the power of n. You should recognize this as the irrational number e. This is equal to e, and importantly for the ratio test, e is greater than 1, which means that this series is divergent. So using the ratio test, we evaluated the appropriate limit, found that it's equal to e, which is greater than 1. Thus, our series, n to the n over n factorial, is a divergent series. Let me know in the comments if you have any questions, and be sure to check out my Calculus 2 course and Calculus 2 exercises playlists in the description for more. Thanks for watching.